There we are. All right, back from technical difficulties. Yeah, good afternoon, Jan.
Good morning, Michael.
All right. Yeah, it's been, well, in addition to being an interesting morning this morning, just trying to get everything up and running. Um, yeah, it's been kind of a whirlwind of activity. Um, yeah, we uh, got some new capabilities. Like we talked about yesterday or last week, demonstrating uh, different processes within Docker uh,
Mm.
connecting through a replicator. And um, so over the weekend, I got as far as the processes connecting through the replicator, and then I was like, you know what? This morning I kind of woke up. I really want that to be all the way to Elasticsearch. So, so, me and Claude and or not ChatGPT, but GitHub Copilot. Uh, the three of us all collaborating on this thing. So, all right, we can get it done.
Mm. Copilot made overtime.
Oh yeah, yeah.
Mm.
Honestly, I can't remember. I can't remember my. I know that I was fast before. I know that I was a very productive developer, but yeah, I cannot remember my productivity level from before. Yeah, having these tools available. Now it's just, hey, I want to use Nest in order to connect to Elasticsearch, and you see this thing I'm doing with the dictionary? Go ahead and put that into Elasticsearch. Go generate. Bloop, there's all the stuff. I was like, okay. Run it, test it. Oh, there's a failure. All right. Yeah, it didn't connect to Elasticsearch because Elasticsearch was still starting up at the same time. So let's put in some exponential back. Oh, okay, let's do that. Here's the pattern.
Mm.
Yeah, and just um, because it's seen those patterns a million times. Why should I have to type those in again? It's like it's already seen them.
Mm.
So I'll focus on the new stuff that it hasn't seen before.
Mm.
So yeah,
But
getting all that
in
stuff started. Go ahead.
in the in the text channel of Discord, I saw you wrote something about Jinaga mesh.
Yes,
Anything
yes.
special you want to say about that, or?
Yeah, that is the word that I'm using for a group of containers that are running together. I don't know if it actually has a name. Docker Compose is the thing that creates that group, but that's not a compose. Uh, what is? Let's call it a mesh. Um,
Yeah.
but
No,
yeah.
I asked because I was this week then on the on the technical side, on the electronic side, working a little bit on Mestastic,
Oh.
which is a product where radio communication passes through other nodes
Mm-hmm.
to reach the destination node,
Mm.
which
Oh, okay, right.
which also exists in Wi-Fi connections. So instead of
Mm-hmm.
having one central node and everybody makes a direct connection to the central node,
Mm-hmm.
you can pass through your neighbors to reach your destination.
Yeah, yeah.
And so I said, why mesh in Jinaga? Um,
Yeah, yeah. Not exactly the same thing,
no,
but
it's because we have a cluster of replicators.
yeah. Right now, one replicator and uh, two processes, custom application processes, and Elasticsearch. Um,
Mm.
but yeah, eventually it will be multiple replicators, and so yeah, the mesh idea will actually really start to take shape because the replicators will be talking directly with one another and
Mm.
moving data from one end of the of the network to the other based on based on who needs it.
Mm.
Yeah, so fun stuff. I'm pretty excited about this demo. So let's go ahead and kick it off. I think I need to start up Zoom because I was kind of holding that as a backup. It's like, okay, if we can't get Discord working,
Mm.
let's see if we can get if we can just do this over Zoom. But
Mm.
yeah, fortunately, uh, got got Discord connected. So yeah, if there's anybody out there that would like to join in, have a chat, we are available. Go to immutablearchitecture.com in order to find the link and tell us your journey on distributed systems and immutability. Okay, so I've got the share started. I am uh, switching over so that other people can see as well. All right. Yeah, I think everything is up and running. So you should be seeing Docker Desktop.
Yeah.
Okay, and here we have Ubuntu with the university system mesh. So um, if you would like to follow along, you can go to github.com/Jinaga/university system, and there's the repo for everything that we're doing, and you just pull that repo, and then there's one command to get it all started. You just well,
You just got.
I'll do it as 3 commands. Yeah. So
I'm gonna follow because otherwise I will be lost.
all right. So we'll start with Docker Compose pull,
Mm.
which we talked about last time, and that checks the Docker Compose file for any images, and make sure that you have those images locally. So you can see it's pulling Elasticsearch, and then backend replicator is using the Jinaga replicator image, and it's doing a pull on that one as well. Which
So for importer
yeah.
and indexer, you already had the latest images on your computer.
Yeah, those are not based on an image that is published, but instead those are based on images that you build. So that's the
Yeah.
next command, docker compose build, and that runs the Docker build for those 2 images. And so I'll show you the Docker files for all that stuff, how all that fits together. But first, I want to show you this thing working. This is cool stuff. So it's got to yeah, that's kind of interesting. So in order to build, it does have to pull some images. It's kind of interesting that it didn't look through the Docker file that ran the build and say, oh, that's based on this image, so let me pull that one. It just said, nah, no pulls necessary. But interesting. Okay, so yeah, it's run the .NET build on those 2 images, and now the third
Mm.
command, docker compose up. So before I run this, you can see nothing up my sleeve. Here I'm trying some Kafka stuff, so I've got Kafka and Zookeeper under this little mesh here. So that's fun stuff. But docker compose up, that's going to create this university mesh here, and we can see everything scrolling by from all 4 of those containers. So you can see them kind of interleaved. We've got the backend replicator, we've got Elasticsearch, and right here we see indexer. It's indexing some stuff, and that's kind of interleaved with the backend replicator. So so the backend replicator is saying, okay, I've saved some facts, and now I've loaded 5 of them. Okay, we're going to index a few more. Oh, well, that means I need to save a few more facts, and then load a few more. Oh, let's index some more. So you can see those 2 things talking to each other and getting all their work done. And way up at the beginning, you would see, yeah, here's all the replicator starting up. Pretty logo there. Here's the indexer starting up, indexing the course offerings. And somewhere in here is an importer. Yeah, there it is. The importer is importing some courses. So those things are talking to each other in order to get some stuff indexed. So
So the
yeah,
importer is getting it from an external database or from an external text file or whatever.
that's the thing that I'm simulating. It's not doing that yet, but
Mm.
that is the idea. Is that it's going to be at the edge, talking to something else to get data, puts that into the Jinaga data uh, store that's within the mesh or the fabric, whatever
Mm-hmm.
term I end up using. And then, so then it talks to its replicator, and that replicator says, "Oh, you're interested in that. I'm going to send that over to the indexer." And the indexer is at the other edge, where it's talking to Elasticsearch. Um, so you've got these edge-to-edge clients, and then a bunch of replicators in between. So if we pop open this thing, we can see the importer has finished. It just had one job and then it terminated. Um, in the future, that's going to keep running and keep looking for new stuff to import. But right now it terminates. And we've got Elasticsearch running at 9200. So when we pull open Elasticsearch, this is what you get. Hey, it's for search, for search. And so now we can go to offerings, and we can see, hey, this is an index. This is just describing the index. It's got a few keywords in there. And then in order to see what's in it, we can go to _search. If we get from _search, then that just pulls all of the records that are indexed in that collection.
Mm-hmm.
If we were to post to search, we could post a query as a JSON object and do all that fun Elasticsearch stuff. But right now, just demonstrating that I was able to post a few courses. We've got CS 501, 401. So these are the course code, course name of a particular offering. So right now, no extra information about that offering. That's going to be the next step. But yeah, so these are offerings of courses within a semester by an instructor at a specific location and time.
Mm-hmm.
And they're all indexed in Elasticsearch. So how did that happen? Well, let's go to Visual Studio Code. Oh, I need a new .NET SDK in order to run the notebook. Well, that's fine. Today is not a notebook demonstration, although this is a really cool notebook. I'm really happy with how this is turning out. But today, we're talking about the mesh. So let's start here with the Docker Compose. So we're pulling together a set of services. So here is the Elasticsearch service. So that's a container called Elasticsearch based on that particular Elasticsearch image. This is an old version. At version 7, Elasticsearch changed their license in order to combat AWS, which had just taken the open source project and put it up as a paid product. And Elasticsearch is saying, hey, that's actually our business model. So okay, relicense it so that you're not allowed to do that. And so AWS forked it from this point and moved forward, and Elasticsearch changed the license and moved forward. But yeah, if you want an MIT license version of Elasticsearch, that's the one. So it's old, but it still does the job. So we've got that set up with its own little volume here called ES data that we mount to this internal folder. The volumes are shown right down here. We just have that one for right now. And then we've got our backend replicator. So this is the Jinaga replicator. Yeah, right now just using latest. I should change this to an actual version number, but this is evolving so quickly. Let's use latest until we kind of bake it. And so here we are exposing port 8080 so that we can actually hit it from the outside and see what it's doing. But yeah, eventually I'm going to take that away, and it's not going to be exposed. It's just going to be internally accessible to the different processes. So here I mounted three different folders, three folders within the mesh project that give us our policies, authentication, and subscriptions. And so no security policies right now and allow anonymous right now. Those will evolve over time, but yeah, we've got it set to be completely wide open. And so we've mounted those to these paths as read-only. We just want the replicator to be able to read those files. It's not going to write to those files. Now these are the two containers that I built from source. So they've got, instead of an image, they've got a build step. So I want to build from this source folder. So kind of change directory over here before you start the Docker file. And then use this Docker file. So from that source context, go to university importer Docker file and university indexer Docker file. And then once it's done the build, then it sets up some environment variables and sets up a dependency so that you can address the other container. So that tells us that I can just look up back in replicator and I should be able to find it. It's that guy. Yeah, this one also depends upon Elasticsearch because Indexer is going to pull from the replicator and talk to Elasticsearch. So you can see we've set up a little network of 4 containers, and they're connected in a
let's call it a mesh.
specific way. Yeah, it's kind of meshy. Yeah, it's an acyclic mesh, so you could also call it a spanning, or a tree if you wanted to. Computing a spanning tree of a mesh get you a subset anyway. So yeah, that one. These both use the backend replicator is the as its replicator URL. They both use the same public key. Right now, I just put some text in there. It isn't even parsed as the as a public key because there's no authorization rules. So, but then yeah, eventually there will be the whole process of initializing a single use user and creating the environment from there. So that's all going to be demonstrated as well. And so then this one knows its Elasticsearch URL and can talk to that. So let's start with the importer, because this is kind of where the information comes from. So we're doing a 2-step Docker file. So the first one uses the .NET SDK and calls that the build container. Is container the right word? I don't know. It kind of acts like a container that's building an image. And then you take a snapshot and that becomes the image. But yeah. So we want to start with the .NET SDK and then first of all copy in these CSproj files. So that's all we've got is some CSproj files. Now we can do a .NET restore on the importer CSproj. Once we've done the restore, then we can copy the rest in. Switch to source university importer and just do the build. So build importer, publish importer. And now we've got the build product in the app.publish folder. And then we switch to creating a new image based on .NET Runtime, and we copy from the build image this app.publish stuff into our app folder. And that means we can just say .NET University Importer DLL. And it starts. So the Docker file for Indexer looks very similar, almost as if it was copied and pasted. And so yeah, let's take a look at the program. What's this doing? Okay. So first of all, get those environment variables. I like this pattern. I don't know why more products don't use this pattern. If one thing went wrong, tell me everything that went wrong, and then quit. It's just so easy to say, oh, if this is null, then write this out and quit. Oh, if that's null, write that out and quit. And then you have to go one at a time. We're past that. But, yeah, so get those environment variables. And then we create the Jinaga client using the replicator URL as the HT endpoint. Set up a few top-level facts. So we've got the user that created the university. That's that single-use user is what that would ultimately be. And then we've got this organization, which is our multi-tenant idea within the university. And then we can start creating some courses. And then some instructors and semesters. And then just hooking those all together. So just run through, create 100 random offerings, and just hook stuff up. So with this model, now I have I've pulled out location and time and instructor. Those used to be predecessors of the offering. But now I've pulled them out so that they are successors, which means that you can change the location of an offering, or the time, or the instructor, but it's still the same offering. The things that you cannot change about an offering are course and semester. So if you sign up for an offering and then it turns out that it's going to be one semester later, no, that's not the same offering. Something went wrong there. Or I signed up for computer science 101 and then this is chemistry 301. I said, wait, no, I'm not going to be successful in that. So not the same offering.
Not as interesting.
Yeah.
Depends on who it is.
Yeah, I'm only speaking about myself, but yeah, so I went to A&M many years ago, Texas A&M University, and so, in fact, yeah, I think this number right here is the code for Texas A&M University and some registry that I found. So okay, I'll sneak that in there. But yeah, computer science or no. Chemistry. Wait, no, it wasn't chemistry. It was history. Yes, history was the only the course that I got that I failed and had to repeat. So, yeah. Then there's that old saying about history repeats itself, and say, no, I repeat history.
No, history even worse.
But yeah, for chemistry, it was D's for degree. Let's get on through it. Because chemistry looks like math. They've got those little equations that tell you, oh, these molecules, you're supposed to be able to balance it with the output. And it's like, oh, okay, I can solve those equations, and I would get solutions that actually didn't, the world didn't work that way. So, but the equation balances. Chemistry doesn't make any sense.
I think it must be very interesting once you know it, but
yeah.
It's with a lot of things. So
yeah, my roommate was a chemistry major, and he absolutely loved it. He also did some crazy things in the room. He probably shouldn't be using ammonia and I don't know what else he brought into the room. It was like, but hey, it was interesting to him.
But apparently he knew the limits because you still you survived.
Yes.
So
yes, and he always wears glasses. So yes, like you should probably not come in until you here put these on. Okay. So yeah, that's what the indexer does, and you can see that after it goes through those 100, it just terminates. So importer. The importer, what I will then make it do is watch a folder, and then I'll mount that folder so that from the outside you can drop some files into that folder, and then once it sees them, it'll go through this process and add them to the Jinaga dataset. Um, and that would allow me to demonstrate some really cool things about idempotent processing. So it'll be able to check to see if it already has that data, and if so, not create any new facts. And it can do that by investigating some other facts that it puts into the data store. But
So automatically,
yeah.
Jinaga, if it creates a fact and the fact exists already, it returns that fact. So,
Yes, yes. So basically using that uh, while doing file processing. So this right here
mm,
would not be allowed because if so you're processing a file, you read a line from the file, you say, okay, I need to create an offering, so new GUID for that offering. Well, you've just guaranteed you're going to create a brand new offering. Um,
yeah.
so that's a non-deterministic operation. So you want to be sure that all of the file processing operations that you do are deterministic, that produce these records. And if you absolutely cannot do something that's deterministic, then you have to have some additional record keeping, which you can put into the model itself to um, to prevent duplicates, or at least diminish the likelihood of duplicates.
Mm-hmm.
So there are
But
some
so,
operations you just cannot prevent.
but so imagine that in the import file, you have, for example, 2 times the same course,
Mm-hmm.
but with a different key
Mm-hmm.
in the import file.
Yeah.
But if during the importing we forget about that key, Jinaga will make a single fact, and so that will be the fact that plays in both relationships.
Yeah, yeah.
So
It all depends upon the model and that
yeah,
causality. So where is the key? That's the important part. Um,
mm,
so like here, an offering is unique based on course, semester, and GUID. Um, and so
mm,
at first I ran it like this. So the offering was unique based on course and semester, and the behavior that I got, as you might expect, is that every offering of CS 101 within a particular semester was the same offering, and then it just had multiple locations, times, and instructors attached to it. And it's like, oh, okay, that's not the intent.
mm.
So I had to add this in order to distinguish them. So
But
yeah,
instead you could have taken into account the location and the instructors, so
yeah,
that
but
core semester location instructor has to be unique to identify an offering.
yeah, but then you run into the problem that now you have put location and instructor, and maybe even time into the identity of the offering, which means that you can't change those things. So the way that I um, rearranged the model, I wanted to demonstrate that you could have an offering that you've replaced one instructor with another. Well, you still show up to that class and you still learn. So you've registered for that class and you've taken that class. Um, that should be an allowable operation. Um, or if we need to change the time, then you've still signed up for that class. Oh, it's now going to be at a different time or at a different location. So, um, so those are the things that by knowledge of the domain are mutable, that they can change. But these things, by knowledge of the domain, are immutable. So I wanted the model to reflect the domain in that way. But yeah, that does mean that if the input file, the input file will probably be like a CSV that just has all this information, bloop, just written out. If somebody goes in and changes the time in the CSV file and then re-uploads that, I want to see that as a time change for an existing offering, not as a brand new offering at a different time. and so one way that if you're in CSV land and you're thinking about that problem, how do I represent that different intent? Is that you might have an ID that you put into the CSV. So this is this offering ID. So this course, this semester, blah blah blah, and so now instead of this being a non-deterministic operation, like creating a new GUID as you're reading, this becomes a deterministic operation. It's based entirely on that record. You just load that in.
So you copy that GUID with another timing, for example.
Yeah. Yeah. And then exactly this line does what you said right at the beginning, is that, oh, I've already seen that course that semester with this ID. So it's going to give me back the existing offering. And then I will be able to adjust the location, time, and instructor. So, yeah, that is coming, and that's not going to complicate this code too terribly much. We will do things like, now that we've got those offerings, search for all the locations of that offering, and then see if the one that's in here is new. So if I get back just one offering or one location, and it's the same building and room, then I don't create a new one. But if it's empty, or if the building and room are different, then I'll create a new offering location and use that set of priors as the predecessors here. So you can keep track of the updates. So that's that is what's going on there. And yeah, this interplay between offering and instructor is going to be kind of interesting. So you need to be able to import your list of instructors. If you hire somebody, you want to know that they're a different person, or if they change their name, you want to be able to update that instructor record and know that it's the same person. So all of that has to be represented in the causality of the model, and then that will be reflected in the way this code is written. So that's the importer. Now let's take a look at the indexer. So this one is the wow. So yeah, we check our environment variables, and then here I'm to make things easier for you to see here, I'm creating this Elasticsearch proxy object, so we can take a look at what that does. But go ahead and initialize that, and then do the same thing here. Jinaga client, create a brand new client, and so then we're going to start with the same organization and semester. Or we're going to start with the same organization, and in this case, we're going to say, well, our spring semester of 2022 is the current semester that we want to index. So so now we set up our specification. So I'm looking for all the offerings in that semester, and then I want to make sure that the offering is not deleted, and I do not have a search index record. So this part is interesting in that if I control click is not working. Oh, must not have loaded the C# stuff. But go to search. Actually, I'll go to this bookkeeping file, and this is where I am defining facts that are specific to bookkeeping for this process. All of the model facts are in here. So we've got student stuff, registration stuff, course stuff, with all the relations, so we can see all that stuff working. But this file, this one is not shared. This one's not part of the university model. This is specifically for the indexer to do its work. And so I didn't put that into this university model package, which gets shared by these, project, which gets shared by these two projects. But instead, I made it just part of the indexer. So, so now the indexer is making sure that it's only finding those offerings that have not been deleted and have not been indexed.
Mm-hmm.
So what does it mean for that offering to be indexed? So it's going to subscribe to that specification, and then every time it sees an offering, then it's going to get the hash of that offering, and that's going to be the record ID that it uses inside of Elasticsearch. So here we see kind of the idea that we were just talking about, but in the opposite direction. We're generating a deterministic ID for use in an external, an off-model storage location. So that way, if we find ourselves failing halfway through, and we've already indexed the record in Elasticsearch, but then we failed to create our search index record, then next time we start up, it's going to produce the same record ID. So it won't have an abandoned search record in Elasticsearch.
Why would we fail to look it up?
Yeah, there is a there's a gap between these two lines. So yeah, things could just terminate right there. It could also be that the gap is within this index record function. So if I pop in there, oh yeah, control click's not working. Here's the proxy. So I go into index record. Here I've got the exponential back off stuff going on for kind of wrapping around the index or the Elasticsearch API. But right here we're actually making a call to index a document. This is one of those places where we're leaving this machine and we're awaiting a response back from the other side. So it's always possible for the message to get there but not be able to get back. So I think that's probably the most likely failure point that would lead to this scenario. That I've successfully indexed this search record in Elasticsearch, but some network hiccup, and I can't get that response back to you. So ultimately, we'll time out. We will, if we were to retry and make it the second time right here, then the search record has already got the ID in it, and everything's fine. But if we're not able to recover this way, and everything times out, then we find ourselves out here, and that will either throw an exception or return false. It's set up to return false. But if it just throws an exception, it's going to throw that exception all the way back into Jinaga, which is is coded to go ahead and log that exception, but then continue with the subscribe. It's like, I don't know what to do with this, but the point is that we have found a record, or we found an offering. This offering has not been indexed, and so we called this function with the intent of creating this search index record. So there's nothing preventing us from calling this function multiple times. The thing that ultimately stops Jinaga from calling this function is the existence of the search index record. Because once I've created it, now the offering no longer satisfies this condition, and so it's not going to be It's not going to be uh, given to this code the next time it runs. So yeah, that is the indexer. Yeah, we just keep running until you cancel, and then gracefully stop. As it turns out, Docker doesn't gracefully stop things. It doesn't send any kind of cancel key press. It just it sends a SIGINT. So maybe I can modify this code to respond to SIGINT. But yeah, that's the code that you have to write right there. That's yeah. This is yeah. Let me get that all lined up on the screen. Okay, that is thumbnail right there. Because all you have to do is write this code, and everything's right up. It has figured out what you care about, and because you've written subscribe, it's keeping that live connection with the upstream replicator. So as soon as that replicator learns about those facts, it tells you. And then once it tells this process about those facts, the Jinaga client calls the function. It says, okay, do something. So that's that just makes me so happy. That's what microservices should look like. A microservice should be that function that fits on the screen.
But so at the same time is importing the records, and immediately afterwards is indexing them.
Yes.
Yeah.
Exactly. Yep, and yeah, you can see there's nothing in importer that says, okay, now that I have saved these things to the database, go ahead and publish an event. Yeah, it's like, no, I'm just saving facts.
Mm-hmm. Why would you publish an event? Jinaga is all about saving facts.
Yeah.
Mm-hmm.
Yep. The kind of the pattern that you'll see, like if you take a look at event-driven architectures that are based on RabbitMQ or Kafka or maybe Kafka applications tend to do things a little bit better. But yeah, if you think about something that's based on a queue, then the queue is a temporary transport of time-based events. That this happened, and I need you to know about it, and all the information that you need to know, I have to know what you need to know in order to put it into this event and send it to you. And then you get it on this side, and it would be, okay, I've just received this event. Let me check my database and see if I've got the information for this one. Or maybe there's some extra stuff that the publisher didn't know I needed, and so I need to go out and get it from some other microservice. Put those things together, and then update my own database, and then tell you that I processed the event. So that actually pops it off the queue. And if you if you fail before you get to that pop off the queue, then you're going to get called again. So just the same argument that we just talked about. The difference is in EDA, you basically say right here at the end of your function that you're done. And the thing that called you knows, okay, we're finished with this event, now we can pop it off. In this, very subtle, but that's moved into your function. Once this succeeds, you're not going to get called again. But but that has huge ramifications with eventual consistency and idempotent operations, all that stuff. So yeah, the next step, so you can see all of these things are to be announced, TBA, um,
Mm-hmm.
and so we've got uh, the record ID inside of this search index record. So I need to create a excuse me, another specification that is looking for offerings that do have a search index record and um, they have a location or a time. And so now I'll take that record ID and I will call Elasticsearch to update that time. And they do have a location and they do have an instructor. Um, so I'm going to model those as three different additional specifications and make those update calls to Elasticsearch. And that will finish out that part of the demonstration. Combine that with making this read CSV files, and now you can just you can play around with it. You can drop some CSV files in it, see it do all of its things, and then go to Elasticsearch and do a search, and yeah, it's all there. Um, yeah, and you can peer into Docker here and see the things talking to each other. Yeah, like if I go here, I can take a look at the backend replicator just by itself, and I can see these counters being incremented. And then we attach Prometheus to this, and now instead of looking here to see these counters being incremented, you can watch a little graph.
Mm-hmm.
It'll be fun.
That's indeed nice.
All right.
So now all the elements are working together.
Yes.
Yeah.
Yeah. All there. Just um, need to flesh them out a bit more. And yeah, I think I'll. So I've got that diagram in the book about what this university system should be shaped like. So I'll be fleshing that out as well and adding more components. Excuse me, mountain cedar. But yeah, so this is one of the paths through the system. There's going to be another path where the students can use a portal in order to register for courses. So that portal is going to be hitting Elasticsearch for them to do the searches, but then they're going to be using that information to um, to set up their own registrations and then look at their own schedule and all that stuff. So so yeah, I'll at the very least have a simulation of that, if not a full-fledged web application. So, but yeah, I want to show that part of the system working too.
But you spoke about that exponential backoff.
Mm.
I already forgot where you where you implemented it in the whole picture.
Okay, yeah.
You just mentioned it and I forgot it. Where
Yeah,
where was that?
that was in my wrapper around the Elasticsearch client. So the Elasticsearch client, you make a call to it, say, okay, I want to store this record. If it fails in that network connection, it just throws an exception, says it can't do it. So so yeah, I put the exponential backoff around that because I'm starting everything all at the same time with Docker Compose up. So so yeah, the indexer might have work to do before Elasticsearch is fully ready. In fact, that's probably the case. It's the slowest of the containers to get started. And in fact, the same thing happened inside of the Jinaga client. So I didn't have any kind of a low-level retry in Jinaga if you were using the in-memory store. if you're using the the SQLite store, then
There we have it.
whenever you save a fact, it saves it locally to SQLite, puts it in the queue, and then um, triggers the background thread to say, okay, go ahead and process your queue.
Mhm.
Meanwhile, it gets back to the user and everything's happy, and that background process is the retry logic in it. So so yeah, with this one, I could have either said, okay, I'm going to set up a SQLite store, which I might eventually do. That's kind of cool. Um, or like in this case, I said, you know what? I really want this to work out of the box, even if you're doing in memory. So the very simplest thing that you do should work. And so I put exponential back off inside of the Jinaga client. So now you can configure your retry count um, and your timeout and all that stuff when you set up the Jinaga client.
Mhm.
So that's one of the improvements that I made this week.
Yeah, so that message
Mm-hmm.
coming in.
So I say, no, I just want this to work out of the box.
Mhm.
I don't want you to have to think about these kinds of connection problems when you're just trying to write your application. So
Mhm.
infrastructure and application logic, separate decisions.
Now, at a certain moment when I saw these messages coming in, I was thinking, is Michael working on the fact that you can, as a client, connect to a replicator? And if it doesn't work, you go to another replicator.
Mm,
Um,
yeah, I have not worked on that feature
mm,
yet. Um, although I have added to the JavaScript version. Um, wait, no, I've so far in the JavaScript version I've added at the configuration level you can give it a list of replicator URLs. Um, I have not completed that all the way through the plumbing where it's actually going to try to connect all of them. But yeah, there, um, yeah, with it, basically, I wanted that capability within a replicator itself to connect to multiple upstreams and create a
mm,
cluster.
mm.
So, so yeah, they all know about all the others, or maybe there's five and each one knows about three others. So you create a
Yeah.
little star pattern.
Mm. No, the idea was if you replicate the client data to a replicator and the replicator fails, that you can just connect to another replicator,
Yeah.
and that at the same time you keep the data local
Mm-hmm.
until you have at least until it is at least available on two replicators.
Yeah.
Um,
Yeah. So yeah, there's all of that consensus logic.
mm,
Well, that's not really consensus, but um, yeah, that redundancy logic.
mm,
That yeah, that's kind of a layer on top of the consistency logic that's already built into Jinaga. But yeah, you're right. I do want that. Uh, I do want that to be something that's just available to you to configure versus
mm,
something you have to code yourself. So yeah, that will be uh, that will be added to the client at some point. I don't know if I'm
mm.
gonna do that for this demo, but well, yeah, this demo is going to be it's going to be evolving for quite some time anyway. So at some point when I do it, I probably will come back to this demo and show it in this demo.
Mm. And also on the side of the import, you could have two importers running
Mm-hmm.
because if everything is idempotent,
Yep.
it doesn't matter.
Yep.
So if one of the two fails, the other continues.
Yep. Exactly. Exactly.
So it becomes a very resilient network.
Mm-hmm. Yeah. Yeah. And so many systems try to solve these resiliency problems on top of mutable storage and um, things that don't guarantee consistency. And so they're trying to solve consistency and resiliency at the same time. Um, Kafka comes to mind. That So yeah, I'm reading this book in order to study for Kafka certification, and it's got all these little gotchas. If you configure something like this but forget to turn on that, then you could get some duplicates and say, well, yeah, I can reason through that and see exactly why that's the case. So why allow me to configure that that way?
Mm.
Yeah, I'm gonna have to go back through and make a list of those things, and that's gonna be kind of an uh, eye-opening post to say, okay, this is the reason why. Reason through it, and then hey, apply these techniques, and a lot of that reasoning is baked in. Um,
Mm.
that's why it's really important to bake causality into your model. And now that it's baked into the model, a lot of these things are derived mathematically. Versus, with event streams, causality is not baked into the event stream. Um, so it has to be added in the infrastructure. So if in Kafka, if two events have to go in the same order, then you have to put them into the same topic, because
Yeah.
order is guaranteed at the topic level by the infrastructure itself. Um, and uh, and then you peer under the covers and you say, well, that's not always 100% the case. Um, you see different. Well, I won't say that's not 100% the case, because you have offsets. Um, but yeah, it depends on the thing that's consuming them. Anyway, it gets complicated, and you have to. That's the whole point. You have to think about those complications when you are configuring Kafka, and when you're building an application based on Kafka. Which is why there's a whole bunch of reading for a certification. Um, and yeah, we have math, so let's use the math. Let's build causality into the model, and then take advantage of that.
Mm.
So yeah, I'm not going to claim that Jinaga is a superior product to Kafka. I mean, Kafka's been serving large corporations at great scale for many years, has a huge community. Jinaga, very few people have tried it out. I'm finding things that need to be fixed every week, and so yeah, still a lot to catch up. So yeah, it's just,
But,
it's the math. The math
mhm.
is superior.
But if the base is healthy,
Mm-hmm.
then the rest can build on top of it.
Yeah.
Good. I'm curious for the next step in this.
Yeah. Yeah. It's going to be fun.
Mm.
All right. So yeah, got started a little bit late. So yeah, got to get headed to work. But yeah, next week, yeah, we'll see some progress here.
Mm.
Will you be able to do any work on DWS before next week?
I will see. I will see. Because it will be the weeks after, the 2 weeks after, I will not be there.
Mm-hmm.
So it would be nice if I can still. I'm gonna try. I'm
Yeah.
gonna try.
Excellent.
Uh,
Yeah. Well, if you run into
but,
any issues, bring the issues. Let's work through them on the
mm, okay.
in the stream.
We
That'd be
do,
good.
we do it. We do
Yeah.
it that way.
Okay.
Because I first have to fix a few things in the model there. Don't remember exactly what, and then yeah, continue with the perhaps leave the I will leave the combo box for later time
Mm-hmm.
and just continue in the model. That might be more productive for the moment.
Yeah. Yeah. Yeah.
Mm.
And if you need help with the combo box, if that's causing issues, then I can take a little bit. Yeah.
Mm.
Uh, a little bit of that. See if I can
All right,
make stuff work. So yeah.
Michael. Thanks you very much, and see you next week then.
Very good. See you then.
Okay, bye
Bye.
bye.